In the question number 6, two blocks of mass 2 kg and 1 kg are placed in a accelerating trolley. If the surfaces are smooth between blocks and trolley, then tension T in a string connected between the blocks. And the important thing is that there is no friction. So you can solve easily, because if I go for FVD, then normal force will manage by the weight, so I am not going to concentrate. And first I am looking to find the acceleration. Suppose acceleration of 1 kg is A1 and they are connected, so acceleration of 2 kg will be A1. If I go for this value of A1, then first I will write the force, that is 40, and the total mass 1 kg, 2 kg, so this is 3. 40 by 3 meter per second is the acceleration, right? And if I go for the tension, so in the case of block 2 kg, tension T will act on the right hand side and there is no force on the left hand side because there is no friction. So if I use the second law of motion, F equal ma, will write T equal mass into acceleration, that was A1. So when you will place the value of A1 means 40 by 3, you will get the value of tension 80 by 3 Newton. So this is how you can solve. So my option number 1 will be the right choice. So let's move on question number 7. In the question number 7, an object of mass 10 kg is at rest on a smooth horizontal xy plane. Now a force this is applied on object, then velocity of object at t equal 5 seconds is. So this question I can solve by using impulse momentum theorem. Change in momentum F dt. We know this formula. So first I am going to write the value of change in momentum. So I need mass. The value of mass is 10 kg. I need final velocity, and question is asking to us an object, then velocity at 5 seconds. Let us consider this is v. So v minus 0. Okay, so an object of mass 10 kg at rest on a smooth. So we can choose initial velocity is 0. And the time limit according to the problem, that is 0 up to 5. The value of force this 9t square I cap plus 4 times of t j cap Newton and dt. So from left hand side I have 10 times of v. When I will integrate, then 2 plus 1 divided by 2 plus 1, so you will get 3t cube I cap plus 2t square j cap. The limits are 0 up to 5. So when you will use the limit, you will get velocity vector 375 I cap with 10 times of v, because 10v is there, plus 50 j cap meter per second. So you can divide by 10 also. On the right hand side, when you will divide by the 10 and take the then you will get the velocity vector is 37.5 I cap, because that was 50 j cap. So when you will divide by the 10, you will get 5 j cap meter per second. So this is how you can calculate. So my answer number 2 will be the right choice. So let's move on question number 8. In the question number 8, in a shooting competition, a contestant fires a bullet of mass 100 gram with a speed of 400 meter per second on a soft plywood of thickness 5 centimeter. The bullet emerges with 4% of its initial kinetic energy. Then emergent speed of the bullet is. According to the problem, I can write final kinetic energy will be equal to 4 upon 100 times of initial kinetic energy, because question says the bullet emerges with 4% of initial kinetic energy. So now the formula of kinetic energy half mv square, mass in terms of kg will be 0.1 into v square, 4 upon 100 initial kinetic energy. So first 1 by 2 into mass 0.1 in terms of kg into 400 square. because speed was 400 meter per second. So you can see here, I am looking to find the V, this. So when you will calculate, you will get V equal 80 meter per second. So my option number third will be the right choice. So let's move on, question number 9. In the question number 9, for a system shown in the figure, spring constant K is 400 Newton per meter. When spring in its natural length, two blocks touch each other. Now block A is pushed towards left. The compression acts in the spring such that block B leaves the contact. This is important point, contact, leave the contact, means normal force will become 0. At the topmost point after the collision, consider collision between A and B perfectly elastic. This is another important hint. All surfaces are smooth, okay, and you can take M is equal to 1 and G is equal to 10 meter per second square. So you can solve this question quickly. Suppose this is my block number B. I am going to concentrate first block B. So you can make normal force and mg will act in downward direction. Suppose this is the speed v. So this is a circular motion. So I can write here mv square by r. Centripetal or centrifugal we can select, and radius is given 4 meter only. Now the main important thing in this question is that, so I am going to use when to leave the contact at initial point, and that point you can take normal force is 0. So if I take these two, so I can write directly mg will be equal to mv square by r according to the diagram, right? By this relation I can find v is equal to root gr. When I will place the value of g and r, will get root 40 because g is 10, r is 4, right? But the another thing is that since collision is perfectly elastic, right, and particle have equal masses, so velocity will interchange. So there is no doubt about that. So now I can write half kx square, and that will be equal to half mv square. So now if I place the value k is 40, x is our requirement, 1 by 2, mass is 1 and v is 40. Because v is 40, how is it possible? Because you have the value of this v. V in terms of a square, so we can write directly 40. So there is only one unknown thing, that is x. So when you will calculate, we'll get x equal 1 meter only. So my option number 2 will be the right choice. So let's move on, question number 10. In the question number 10, the linear mass density of the rod is given, this one, 2 plus 6x, x in meter, the position of center of mass if one end is at origin. So this is very famous question and good question also. So if I take this is my origin, so I will write the coordinate 0, 0. According to the situation, x will be 1 meter here, and for the calculation of center of mass, you know, if I take one small element here and the position of this element from origin is x, the thickness or length this element is dx, and I am going to consider mass is dm. And you know the formula, if I go for center of mass, will write lambda x dx divided by lambda into dx, and where lambda is the linear mass density. And now I am going to place the value 0 up to 1, 2 plus 6x into x dx, 0 up to 1, 2 plus 6x dx. Okay, so when you will multiply it with x, you will get 2x and plus 6x square is here. After multiplying the x, when you will integrate, you will get x square and this 2 or divide by 2 cancel ho jayega, plus 2x cube, limits will remain same 0 up to 1. Similarly from here, 2x plus 3x square, 0 up to 1. So when you will apply the limit, we'll get 1 plus 2 2 plus 3, and that will be 3 upon 5 meter. And you know, I was taking this element from left hand side, means from origin, so I can say the position of center of mass will be 3 upon 5 from origin. So on behalf of that, my option number 1 will be the right choice. So let's move on, question number 11.